Good morning, everyone, and welcome to today's PHJV Policy Committee webinar series. Today, Dr. Graham Strickert will be speaking to us about connecting with communities, adventures in community-engaged scholarship, and participatory Corey modeling. Excuse me. Graham, whenever you're ready, feel free to go ahead.
Okay, thanks very much. Thanks for joining, everyone. I'm going to dive right into it. I just want to give acknowledgement to the University of Saskatchewan Global Institute for Water Security, who's been supporting most of this work for over the past 7 years. So I'll start with a photograph. This is a photograph I call Fire and Ice. It's a photo of the Jean Marie River where it pours into the Mackenzie during the spring breakup. And as many of you know, the spring breakups have been happening a lot earlier. And although it may look like there's a fire to the left of the screen, it's actually a sunset. But on the right-hand side, the entire eastern bank of the Mackenzie River there is actually burned, and it burned the previous summer. This was 2015, so the summers of 2014, there were major fires in the Northwest Territories. And we've been working up there for a little while, and it's a pretty special place in my heart, and there's some wonderful people there that we've been lucky enough to connect with. So I'll talk a little bit about that, but more generally about some of the things we've been doing to engage with communities. And I'll dive a little bit into some of the modeling that we've been doing. So first, I want us to remember that there's a real risk of not connecting with communities. So there's several examples on the screen in front of you. In the top left corner is the Murray-Darling. After the Murray-Darling Basin released its plan on clawing back irrigation licenses, farmers there felt like they hadn't been properly consulted, and they actually took the reports and burned them in the street in front of one of the government buildings. We also have Grassy Narrows in northwestern Ontario, where I used to live. Of course, Lake Winnipeg is a sort of failure in both governance and environmental management in terms of nutrient loading, and that's a very large algae bloom that occurred in 2010. And then we have, of course, the Dakota Access Pipeline, and the in the middle bottom panel, we have Quill Lakes, which has been a pretty major flooding disaster in the prairies, combination of extreme rainfall and also wetland drainage. So over the past 7 years, we've been working, doing workshops using mixed methodologies really across the prairies, from the Rocky Mountains all the way up to the Saskatchewan River Delta. And if I don't run out of time, I'd like to really try to get into the Saskatchewan River Delta and why that place is so important. And in fact, I'm right sitting today in the Saskatchewan River Delta in Cumberland House, Cree Nation's Economic Development Office. So we have the headwaters, which is where about 90% of the flow in the rivers comes from. We have lots of irrigation districts. We've got reservoirs. We've got cities along the way. Here's my favorite, where I live, Paris on the Prairie, also known as Saskatoon, and then into the Saskatchewan River Delta, the largest inland freshwater delta in North America. This is a 10,000 square kilometer wetland. It's pretty unimpacted. It's significantly impacted by flows and lack of sediment, but in the delta itself, it's a pretty incredible environment. And then it flows into Lake Winnipeg and onto Hudson Bay. So what we've learned through connecting with communities across this wide landscape is that we really need variety. We need to use a lot of different tools. Sometimes that's one-on-one interviews. Occasionally it's focus groups. We also use Q methodology, or what people might know as Q sorts, mind maps or fuzzy cognitive maps, decision labs, both fixed and mobile, and different kinds of surveys and psychological scales. So I'm going to jump into some of our results. When we first started this in 2012, we asked people to define what water security meant for them. And we started out with an approach to this project that was defining water security for the Saskatchewan River Basin. And when we started connecting with different stakeholder groups across the prairies, mostly watershed planning groups. They said, look, none of this is new, and really you're not going to do this for us. You should do this with us. So eventually we moved from science for society to science in society to science with society as this work developed. And through mix of methodologies, including Q-sorts, focus groups, fuzzy cognitive maps, and surveys, we generated these 5 different perspectives of water security. So on the bottom left, we have a sort of more a limited perspective that only existed in Alberta, and that was the water supply is limited, get used to it. Then moving up to the right, we have water for drinking and for animals, more social and ecological justice. We have water supply that's reliable, water for people and for ecosystems, water for all users and for all time. So we struggled with how to communicate this quite complex perspectives. These are just a snapshot of essentially what the different viewpoints were saying. And we wanted to figure out how to connect them back to the audiences. So I'll stop by saying something John Fowles said, that all good science is art and all good art is science. And I'm not sure why the screen's gone blurry, but we'll soldier on. So one of the things we decided to do was to create a play. Rather than going back and presenting in our standard way using PowerPoint, we decided to turn all of these characters, these different perspectives that we had created, into characters that would interact on stage. And so here you can see a water treatment plant essentially in an argument with a fish in the river. And that argument's being mediated by a golf course owner from a First Nation. Now, in producing this play, there were some significant obstacles. First, we had a very short timeline from hearing that we were successful with the funding for the project. We had about 6 months to write the script, build the sets, audition the actors, do rehearsals, and plan the logistics for a traveling play. So normally plays are written over many years, and the logistics might take 6 months to a year. So this was a really condensed timeline, which made it quite difficult. Nevertheless, we worked with the Greystone Theatre Department of Drama at the U of S, and they really helped us do this, because without them, we couldn't have done it. We also had quite a lot of opposition. One of my colleagues, after reading an early draft of the script, said, in honesty, I did not like the play at all. I do not want to be associated with it or have it played anywhere near where I work. I would not go to it nor encourage anyone to attend. As your colleague, I recommend you quietly find another way to fulfill your goals. So somehow I knew I was on the right track. We soldiered on. We had the script edited by 25 people, including about 15 hydrologists. It's actually quite difficult to make a play that's hydrologically accurate, but nevertheless, we tried very hard, and then we got ready for the traveling show. So it wasn't just a normal play. It was a play where it started out with a board of directors trying to deal with the drought, asking, did you learn anything from the scientific community? And then all of a sudden there's a flood. And when the flood occurs, the board table breaks into these podiums, and the whole production becomes kind of like a game show where the audience has to interact with the actors on stage, and each character is representing a different group. So here we have the water treatment plant, an oil tycoon, a golf course owner, fish in the river, prairie town, and an irrigation farmer. And there were pretty heated debates throughout the performance, but the audience had to allocate resources to each of these people after they pitched to the audience why they should get resources to help protect them from the flood. And then at the end, depending on how much resources the audience had spent, there was this one stakeholder left over, which was an indigenous community in a delta downstream. And the sort of key punchline for the performance was, would it be too much to ask that you remember everyone downstream? And this was a deep dive for us. We'd never done anything like this. But it was really well received by audiences. And we actually tracked the decision-making of the audiences through each of the performances, where we could see, which options they chose and which ones were similar and which ones were different. And we found that there were some interesting bits. So I'll show you just one example. Here, when the flood's hitting the prairie town, only one of the groups chose to build a round belt barrier for the Central Business District, whereas the rest of them chose to build a rapid deployment flood wall around the entire town. But none of the groups chose build a berm around high-value homes, which is typically what happens in a lot of flooding situations that affect towns, is the highest value real estate is where the effort goes to protect. The other thing that we did was that the audiences were split. So there were 5 decision makers that had 80% of the resources, and then the rest of the audience had only 20%. So we created the tension between the decision makers who have resources and decision capabilities and the audiences who are often sort of only allowed to make decisions at certain times and under certain circumstances. So if you're interested in this paper, it's published in the International Journal of Qualitative Methodology. It's called a Pings and Pongs on Forum Theater for Knowledge Mobilization. And it was quite a big hit. So I don't know why these slides are going a bit blurry, but to develop a complete mind, study the science of art, study the art of science, learn to see how everything connects to everything else. So another example we have is a partnership we had with Agri-Food Canada called the Invitational Drought Tournament. Perhaps some of you got to participate in one of the tournaments that happened in Western Canada. And it was an attempt to respond to the hydrological cycle where, we often go through this, intense rain, and then there's a bit of apathy after the rain stops. There's a drought, there's awareness raised, there's concern, and then panic, and then it rains again. And then we go back through this cycle over and over and over again. So Harvey Hill from Agri-Food Canada decided, if we could put people on interdisciplinary teams and have them try and manage a drought, that would be a really positive way. A really positive way to get people thinking about drought when they're not in a drought. So we wanted to understand the decision making within the tournament. So we gave them a scenario of a drought that was built based on reconstructed tree rings from Dave Sachin's work. And we gave them a series of adaptation options, 15 adaptation options they could choose from. They could also innovate and come up with their own options. So here is Dr. Ali Nizami negotiating with the 4 referees about one of the innovation options that he and his team wanted to come up with. Here's Dave Sachin in the background, and Evan Davies and Daryl Corkle, who are kind of all familiar faces in the water world on the prairies. We've turned this into a teacher's guide for classroom-based invitational drought tournaments if anybody would like to try it out on their own. And we also did something that was kind of fun, and this was actually Ali Nazami and I's collaboration, where we extracted the voting patterns from each tournament. So you can see that there's funny things going on. So note that the low scores are good and the high scores are bad. And here, most of the individuals are voting for their own teams, which is not surprising. Individuals are also punishing, so giving poorer scores to the winner after each round. And individuals to other teams are sort of generally fair overall. But what we wanted to do is and here's the referee scores, which are almost a normal distribution, but what we wanted to do was to figure out, could we actually come up with a weighting system that would be the most balanced to select the best choice? So here's random chance. And we ran simulations of the votes. And in this case, you've got individuals more likely to pick the best score when you start balancing between individuals and teams. Fair, but not likely to pick the best. And then over here, up a little higher, we start to get the best score, where we would call it a pure pluralist democracy. But in these ones, the competition is detracting, where the teams are punishing each other and whatnot, which was kind of a fun thing to do. And then over here, these are colluding dyads. So you have essentially only the referee and the teams, or only the individuals and the teams, and not the sort of 3-pronged approach to the voting system. So this was just an interesting experiment to understand, can we actually extract the votes from a game like this to see if we can simulate the likelihood that the individuals or teams are going to pick the same winner after each round. And the assumption that we're making is that the experts have no skin in the game, the referees have no skin in the game, and so we were trying to emulate their scores. Another different example is Experimental Decision Lab for Water Security. This was our 1.0 version of our decision lab, where we had people allocating a limited amount of water to different sectors: industry, agriculture, municipalities, and environment. and then they have an outflow that then goes on to the next region. They allocate. Note that the demands in each region are different. So this is based on Alberta, Saskatchewan, and Manitoba, each with different demands for a specific river system, in this case being the Saskatchewan River. And what we found is that in the most extreme droughts, the best policy is actually the policy that's in place now. That's the Master Agreement on Water Apportionment, where each team has to pass on 50%. But when you're in a moderate drought, say only a 90% flow scenario, a shared risk model actually works better, where people can optimize the allocations to different sectors by communicating with each other up and downstream. Or if you have a free-for-all where there's breakdown in governance between the regions, then essentially upstream gets more than downstream, which isn't too surprising. It's possible to look at how the water was allocated across those sectors under the different policies. And many who've had an opportunity of knowing any more about mathematics confuse it with arithmetic and consider it an arid science. In reality, however, it's a science which requires a great amount of imagination. That was by Sofia Kovalevskaya. So I'm going to dump now into some of our work we've done in the Qu'Appelle Valley. I spoke at the Prairie Habitat Joint Venture in more detail about this last year. But essentially what we did was we created a systems dynamic model in SynthSim to emulate Sparrow. So Sparrow is a statistically based water quality model that estimates nutrient loads based on things like flows, geology, crop cover, rainfall, and many other attributes. But we wanted to create a system that people in the agricultural community could actually play with. We ran some workshops to ask them, which beneficial management practices do you think are the most effective at reducing water quality? Improving water quality, so reducing nutrient loads to streams in terms of nitrogen and phosphorus. And we did that by having people do Q sorts, where they're sorting statements about which BMPs they felt would be the most effective to reduce nutrient loads. So here is the scoring sheet, where they're writing the number of the statements on these score sheets, and then we compare each individual to all the other individuals and see if there are any viewpoints that emerge. And indeed there were 4 distinguishing viewpoints. So some people felt that flow and erosion control in grain farms would have the biggest impact. Others felt that cattle farm and wetland management would have the biggest impact. Some felt that cattle feeding and management in cattle farms would have the biggest impact. And a few participants felt like fertilizer management in grain farms in terms of application would have the biggest impact. So we then created a systems dynamic model that people could actually play with the priorities. They could allocate some of the resources, such as complete relocation of corrals, and then we would see the change from before the BMP to after the BMP in terms of how much nutrients. This is showing total nitrogen across the 12 tributaries of the Qu'Appelle Valley based on Sparrow, and it was able to emulate Sparrow with about 90% accuracy. But what we found was that they liked this, and they liked being able to interact with it in real time. They were frustrated by sometimes people creating models, going away, beavering away for months or years, and then coming back and them not really understanding what had gone into it. In this case, they helped design which BMPs would be considered, and they also told us all the great things and the not so great things about our model. In particular, what they didn't like is that there was no feedback mechanism explaining what the impacts on investments would be towards the agricultural productivity. So that's something that we're working on now. Now, I'm going to shift gears a bit and start talking about Canada's inland deltas. And these are really incredible places that many people don't actually know even exist. But they're complex social ecological systems that really need environmental flows. So here are some Landsat images that show the deltas under different flow conditions. So here we have 2001, which was a very dry period of time. 2012, quite wet, still coming out of 2011. Here, 2011, really wet. You can see all the lakes that are connected to the rivers. And here in 1990, another dry period. 2005, another quite wet period. And then 2005 in July, where there was a pretty major flood that went on. Now, we know that overall there's been less water flowing into these areas. So typically a summer flood 1913 covered 13% of the study area, but now a typical summer flood only covers about 6% of the study area. And my colleagues Tim Jardine and Brett McKinnon went out and did isotopic samples of wetlands in this delta area to see how connected they are to the river. So here's the river going through the middle, and then you can see there's a number of lakes and wetlands that are kind of around the river. And they took isotopic samples to see how often they're connected to the river. And what we find is that the further away from this meteoric waterline, that means the river, the wetlands are less and less connected. And as they are less and less connected, many things happen. So the wetlands with higher connectivity, the category 1, have higher dissolved oxygen and pH, and lower ammonia, turbidity, nitrogen, and total phosphorus. But as they move away from that, the dissolved oxygen goes down, the ammonia goes up. Essentially, it's really bad for life. And the people in these areas describe pretty major transitions of declining biological productivity over especially the last 60 years. So we've been working there for a few years, and then people in the community called us out and said, we would like you to help us develop a plan on water stewardship for this delta. So it's all about protecting the social, cultural, ecological, and economic integrity of the entire delta for today and for future generations. And so we've been working on that for a few years now. So here's a photograph of the planning group sitting around and thinking about the things that they're essentially the things that they care about and what they're most worried about. And we did a visioning exercise in 2014. One of the most common themes to come out of that was water. They wanted to see more water in the delta, less human-controlled floods, and releasing water from the reservoirs upstream to inundate the delta more often than is occurring at this current time. So here's a risk assessment. So here's one of the key items was lack of sediment replenishment in the delta. So the sediment's being trapped behind reservoirs all the way to the Rocky Mountains. And so the water gets hungry, it scours the channel, and then there's a less likelihood that the water is able to connect to those wetlands to boost that biological productivity. Here's some examples of the pre-dam flows and post-dam flows, not just in the Saskatchewan, but in the Peace, Slave, and Saskatchewan. You can see that there's pretty major impacts in terms of changing the hydrological regime, almost reversing the flows, higher flows in the winter, lower flows in the summer than are typical. And the hunters and trappers now are probably only 10% the number that there was before. And of course, people in the delta say if the deltas are healthy, the people will be healthy. So overall, a message was developed by bringing together all the people from these communities to Saskatoon for a workshop. And this was after about 4 years of work in these deltas. And the message was bring back nature's flows, restore our delta's rhythms. There's also lots of structures within the deltas that control the flows, which have been sort of let go because they became too expensive to operate. And so now they're starting to disestablish these, but in a lot of places, these structures have been blocked by debris, and then they're not flowing properly. So I'm just going to share a short video by commentary from Solomon Carrier. This is featured in the film Saskatchewan River Delta.
If you would work with those scientists, then you begin to understand what they're doing, and maybe what we do would help them. Because we want to learn too, right? Because you're only an expert on your little part. You know, that's, if we could share all that information, then we'll be better stewards of this land. That's what I think.
So Solomon is quite an inspiring character. He was actually a world champion canoeer from Cumberland House, and his idea of you're only an expert in your little part. If we could share all that knowledge, we'd be better stewards of this land. That's really the approach that we've been taking. So all this work that I've been describing is not work that I've done alone, but it's with teams of people. And I just want to briefly share about this this follow-on from the Delta work that culminated in what was called the Delta Dialogue Display Tour, which was done in partnership with the Changing Coal Regions Network. And the idea was the communities asked us not to bring back another report. They said they were inundated with reports and they wanted us to bring back something that everybody in the community could talk about. And that the initial idea we had was a sort of museum type exhibit that we would tour around in a truck, and it would be quite simple. And so here's Susan Shantz and Carla Oros. Susan's with Fine Arts Sculpture at the U of S, and Carla is with the Department of Drama Greystone Theatre. Both designers, both artists, and me, a social scientist, working together to try and figure out how we could connect people to what we had learned in the deltas over about a 4-year period. And then here's Ian Rose and Carla standing inside the sculpture that would become kind of the glue that would hold together this Delta Dialogue display. So eventually it culminated in quite a large display that we couldn't fit in the back of a pickup truck. Instead, we had to rent a 38-foot diesel truck, which we drove from Saskatchewan to Yellowknife and stopped off in several communities in the winter of 2017. And in the center of the display was a helix as well as a dream catcher. And then that poured into a number of photographs from people in the communities holding these signs that said something about what the Delta meant to them. And we also had Polaroid cameras, and we cataloged all the photos of the different meanings. And then we had things that the communities contributed to the display as it went along. So the display actually grew as we went, and we started with sort of culture coming from the communities and cultural artifacts coming from the communities. And then towards the outside of the display, we had screens telling the story, some in Cree, some in English, maps about climate change. And this is one of the pieces I created that was taking the river flows in the 3 deltas over 100 years and turning them into sound, so people could actually hear how it had changed over time. And we built a stream table as well to show how deltas formed and how sediment gets trapped behind reservoirs. This was a favorite among the kids. In fact, sometimes we had to kick the kids out at night because they were staying till sort of 9 and 10 o'clock. We also we worked with Nicole Paul, a Cree artist from the University of Saskatchewan, to summarize all the work that had gone on over the 3-day workshop that we held at Wanuskewin. And the key message that she caught was we must be voices for the deltas. So on this front side was the coloring page, and on the back side was a policy brief about how we could better manage dams to boost the productivity of these delta ecosystems. So after a certain level of technical skills achieved, science and art tend to coalesce in aesthetic plasticity and form. The greatest scientists are always artists as well. And I think connecting with communities is as much a matter for art as it is for science. It's often hard to connect with people and to connect with the emotional side and the spiritual side of people just through science alone. So here is a photograph of a whiteboard animation video that was created as a part of all this work as well. You can see this on YouTube. It's called Sweep Whiteboard Animation Video, Delta Ways Remembered. And this is stories from the elders in the Slave River Delta. And here is the exhibit shown in several different communities. This is Fort Resolution. This is James Smith. This is Fort Resolution, Fort Smith, Fort Chipewyan, and this is in Yellowknife on our last stop. And here are some photos that were featured. Here is the display in the Gordon Oaks Red Bear at U of S. And here I want to show this picture. This is Gary Carrier, who really kicked off all of this work from the Saskatchewan River Delta, standing with Bob McLeod, who is Premier of Northwest Territories and many members of the Legislative Assembly. So after all this tour was done, we put it up in the Gordon Oaks Red Bear at the U of S. And somebody on the very last day of our very last show, somebody from the board of directors of the Western Development Museum came in and saw it and wondered, could you bring this to the Western Development Museum? And we were a little bit out of steam, but we decided to persevere and pull an all-nighter and move it to the Western Development Museum, where it stayed for 6 weeks, and there were over 6,000 people that saw it while it was in the Western Development Museum. So that was a real win. And here's the exhibit when it was posted in the Western Development Museum. That was really a lucky occurrence. So I want to acknowledge many of the people who supported this work, and these are just a few of the projects that we've been doing to connect with communities. I want to, of course, acknowledge SSHRC and NSERC, Government of the Northwest Territories, Global Institute for Water Security, University of Saskatchewan, and the Delta Dialogue Network that really helped support this work. The last thing I want to talk about is a follow-on from this is we ran a course called Becoming Water, Art and Science in Conversation. And this was about connecting artists and scientists together, having artists learn from how scientists, different kinds of scientists, understand water, how members of communities understand water, and then what kind of art they would create out of that work. And so you can see a number of different pieces here. We have some photography pieces, some sculpture. These are actually made from sediment from different reservoirs along the Saskatchewan River. Here is an idea that a First Nations elder told one of the artists about trying to stir up the sediment with an egg beater-like boat that would stir up the sediment during high flows to try and carry the sediment downstream. Here are some portraits done by Cree artist Janelle Drever of some of our hosts when we stayed in the Saskatchewan River Delta, and she actually used mud from the Delta to create these portraits. These are temple balls created by Will Hearing that actually used mud from all of the different spaces that we stopped along this journey. And here's a picture of the final show. We also did ice books where the students put riparian seeds into blocks of ice and then floated them into the river in the Delta. So some really cool pieces of art. So the tips I have about connecting with communities for this work and some of the other stuff we have going on now is start the conversations early, listen first and then talk. Don't worry about getting it wrong. Don't worry about getting it wrong, and that can be sometimes paralyzing. Ask questions about protocols, especially if you're working in First Nation and Métis communities. See the value in others' work instead of its value in yours, sort of the beyond the instrumental value of collaboration. Engage early and often, be responsive, make sure people know that they've been heard, let the ideas evolve, and set targets that evaluate the strength of the collaboration. So initially, especially when it comes to the Delta display, we had all these ideas about, computer models and showing them on sort of two-dimensional screens. But by creating a three-dimensional object that they could interact with, that they could touch, that told the story that those models were telling was far more powerful than actually putting the model in front of people themselves. I'm going to skip that bit. And just my final slide. I've broken down these projects onto sort of a plot of accessibility and responsiveness. And so accessibility, I mean seeing the world through different disciplines and worldviews. And then over on the right-hand side, you can see prominence of a single discipline, balance of multiple disciplines and worldviews, and art as a bridge between worldviews and disciplines. And then along the bottom, in terms of responsiveness, is science-driven, community-informed, community-based, and community-driven. And what I think is that if we maximize accessibility and maximize responsiveness, then we can get to that level of the Delta Dialogue Network and the Delta display. And I think that art is a really key feature because it connects not just with people's minds, but it connects with people's hearts. And we can still tell those important stories that are likely to change policy. And I thank you for your time.
Thank you, Graham. Does anybody have any questions for him? If you do, please type it into the chat box below.
Anybody still there?
Here's the question. Graham, great presentation. Can you give some thoughts about how this integration of science and art can be made more available by social media, hoping to attract interests from young adults?
Yeah, I mean, I would say just put it out there. And we did try a little bit of social media. We tried Twitter as we were going through the communities and Facebook, and we had some traction. And I think that we probably could have done a better job. Like if we'd had a person managing the social media as the tour went along, that would be really powerful. Often we don't have that person. But that would make a big difference. It's just having a person who's dedicated to that, because it can take up quite a lot of time, and especially managing the content where, sometimes you'll get people that are trolling that provide negative comments, and that needs to be managed. So I would say having a dedicated person to that. We didn't at this time, but we do now have people that are working on social media on a nearly full-time basis, so that makes a really big difference. But yeah, I think that's quite important.
Looks like we have one more question coming in. Graham, very interesting work. Thank you for presenting this to us. I am wondering whether you can say what the final impact is or was on management of the Delta.
Yeah. To be honest, we're still working on that. I think the biggest impact was getting the word out to people across the deltas that there are other deltas that are going through really similar things. That was probably the most powerful impact, so that they don't feel alone and that they have the opportunity to meet with and talk to people from those other deltas. The other one is getting the word out to upstream people, sort of from the deltas up to the mountains, that these deltas are there and that they're under extreme stress, and the flow of water and the way that those flows are managed is impacting them. That's happened, but it hasn't so far led to any changes in the operation of those flow regimes. Despite our great efforts to communicate with the people that are controlling those structures, there hasn't been a very high level of responsiveness from those entities that these places are important. But essentially, society is making a trade-off against these very large and somewhat intact, although decreasingly productive ecosystems for energy production. And I understand that, but I don't think most people in society actually knew that was happening. And I think we've definitely raised awareness that that's going on, and that there are more and more people that actually know these deltas exist, whereas for a long time, nobody knew that they existed. But as far as impact on the actual flow regime, I don't think we have made that impact yet.
Great. Thank you. Doesn't look like there's any more questions. So thank you, Graham, for your very interesting presentation today. And thank you, everyone, for joining us. And if you do have any further questions, feel free to get in contact with me and I can pass them along to Graham and Hugh. Again, thank you, everyone, and have a great day.
Great.